So again, like I was saying a second ago, if you focus on what we discussed about the relationship between exponentials and logarithms, that's going to be really helpful. So you'll remember on the first page we talked about how we can change from exponential form to logarithmic form, and there were a couple things that you ought to remember. Logarithms are just another way to write exponential expressions, and the answer to a logarithm is an exponent. And so they're kind of like the opposite of an exponential. And we talked about the fact that logs and exponentials with the same base are inverses of each other. We talked about how, if you're really familiar with how to graph an exponential, it just takes a little bit of tweaking to be able to graph a logarithm really well. And here is that point right here. Logs and exponentials with the same base are inverses of each other. So they will undo each other the same way all the other inverse operations that you've learned about will undo each other. Okay, so those are good things to keep track of. We also talked about the natural log. It comes up a lot. It's one of the most common logarithms. So we use that a lot. It's got its own special name, ln. Okay, so we say lnx. There's a ln button on your calculator. That's log base e. There's a common log on your calculator. The base isn't written there, so it's understood to be base 10. And then we went through and we did a bunch of graphing. We talked about domain and range, had asymptotes and all that sort of stuff. And then we mentioned these four things. If you can keep these in mind, then you're in good shape. Again, just restating, logarithms are another way to write exponentials. The answer to a logarithm is an exponent. And if you can't figure something out in exponential form, write it in log form. If you can't figure it out in log form, write it in exponential form. Those four ideas, along with the fact that those two operations, exponentiating and taking a logarithm, those are inverses of each other, can be really helpful. So we're going to take a look at this last page here. We've got several problems to look at. And this is why, we were complaining a little bit earlier about why there are a ton of problems. Some of them are literally this easy. Now, if you stare at this and have no clue what a logarithm is, don't really understand what an exponential is, you can stare all day at this and think, my gosh, there's the word log. There are two 5s. One of them's tiny for some reason. And then there's this 2 written up above. You could stare at that all day and have no idea how to do this. But if you understand how these are related to each other, this is a very, very simple problem. So this function right here is a logarithm, and it has a name. It's called log base 5. This is a function right here, and it has a name. It's called exponential base 5. What does log base 5 have to do with exponential base 5? They're inverses, right? So what do they do to each other? They undo each other. So whatever exponential base 5 did to the 2, log base 5 is going to undo that. And what's the answer going to be? The answer is going to be 2. Okay? Now, it took me about probably 45 seconds to yap all that way and explain why that's the answer. But the answer is just 2. They undo each other. Okay? So if I take a look at this one, here I've got exponential base 7. And the exponent happens to have a logarithm in it, and it happens to be called log base 7. What does exponential base 7 have to do with log base 7? They undo each other. So whatever log base 7 did to the 6, exponential base 7 is going to undo. So what's the answer? The answer on this one is 6. Okay, now that's all well and good if you understand that and you get the idea. I want to make sure we're really clear on this. So if I were to write, let me go back here and change colors again, and I'm going to make this a little bit bigger. If I were to write log base 5 of 5 to the second equals, let's say I didn't know what it was. Okay, now I realize we know what the answer is. Okay, what form is this in right now? It's in logarithmic form, right? Okay. So it's log base 5 of this stuff equals x. So if you were having trouble in this format, you could say, well, I really don't like logarithmic form. I'm going to write it in exponential form. So what's the base going to be? What's the exponent going to be? X, and what should it equal? Should equal 5 to the second. Now we've got an exponential equation. The only way those two things could be equal, because the bases are equal, is if x is equal to 2. So there's our answer of 2. I can do the same thing with this one. So again, let me change colors. This is 7 to the log base 7 of 6. Let's say I didn't know what the answer was to that. What form is this in right now? This is in, careful here, Okay, this is an exponential form. Here's the base, here's the exponent, here's the number that it equals. So if I were going to write that in logarithmic form, it would be log base 7 of, nope, okay. Okay, let's think about this for just a minute. Okay, again, it's one of those things you've got to keep in mind. The answer to a logarithm is the exponent. So if I'm writing a logarithm right here, the exponent's got to go over here. What's the exponent? Log base 7 of 6, right? Does that make sense? The only thing left is where the x goes. Now let's stare at this for just a second. We're going to see a bunch of these in the coming sections. This is called a logarithmic equation. I've got a log on one side and a log on the other side. This is log base 7 of x, and it's supposed to equal log base 7 of 6. The only way those two things could be equal is if x is equal to 6. That's why that's the answer. Okay? So not only does it work if you just know that they're inverses of each other, it also works with that idea that you can have trouble in exponential form, or we'll write it in logarithmic form and vice versa. Any questions there? Okay, so most of them are literally this easy. We can just look at this and we can say, well, that's log base A, and this is exponential base A, so my answer is x, right? Do you see that? Okay, let's take a look at this one. This is exponential base A raised to the log base A of x. These undo each other, answer's x. Okay, it doesn't make any difference what those bases are as long as they're the same. So if this was base 17.2 and this was 17.2 to the x, they'd still undo each other. Logs and exponentials of the same base are inverses of each other. Any questions? Easy enough? Okay, all right, so let's take a look at the next example. Okay, now these problems are just demonstrating some relatively simple properties once you figure out what they are. So this says log base b of b. Now let's go back to what I said yesterday. Logarithms are basically asking a question. This one is asking b to what power equals b? 1. Answer's 1. Now if you wanted to, you could put an exponent on that and say, well, this is log base b, this is exponential base b. They undo each other, so the answer's got to be 1. This is asking another question. It's saying b to what power equals 1? 0. Any number to the 0 power equals 1. This is saying b to what power equals 0? B to what power equals 0? So b to what power equals 0? This is always a positive number. Will it ever equal 0? Nope, never. So we can say no solution. You could say D and E does not exist. There's no solution that exists for that. Okay. How about this one right here? Does that look like it should have an answer? It sure does. I mean, there's a log base 8, and then there's a negative 8 there. We're saying log base 8 of negative 8. You know, I've been mentioning this for a long time, and you heard this in 1010. Can you take the log of a negative number? You can't, and here's why. This is saying 8 to what power equals negative 8. Again, this side is positive. This side is negative. Will they ever be equal? They never will, so there's no solution to that one either. Okay? Any questions there? Sure? Okay, let's take a look at the last couple. I think you ought to be able to solve every one of these without any help. I don't think I should have to show you any of these as long as you've been paying attention to what I've been saying. Do you know what x should be? If you do, great. Double check it and make sure you're right. If you're not, if you're staring at that going, oh my gosh, I don't know how to do that. What form is this in? Logarithmic form. So if you can't figure it out in logarithmic form, write it in exponential form. What would the base be? Base would be 6. What's the exponent? 2. And what should it equal? X. The answer is 36 on this problem. Okay? 6 to that power should equal that number. 6 to the second power should equal x. So it's 36. Okay, this one is asking a little bit different question. You'll notice that the variable is now the base. That doesn't happen very often, but let's see if we can solve this. If you know what it is, that's awesome. If you don't know what it is and it's in logarithmic form, what are we going to do? Write it in exponential form. So that would be x to the 1/2 equals 8. I know how to solve that. I know what x to the 1/2 is. That's a square root, or I could just square both sides, power to a power. That'll turn that into a 1. And over here we get a 64. Is 64 to the 1/2 power, does that equal 8? And is this okay to use as a base? Can you use positive 64 as a base? Yeah, it would be a problem if it worked out to be a negative, okay? You know what the answer is? 3 to what power equals 81? If you know that, great. If you don't, you could turn it into exponential form, 3 to the x. In fact, I think we did this problem a couple days ago. X is equal to 4. Again, if you're good at answering that question by just looking at it, these are not too bad. How about this one here? What is it? It is e squared. Okay, the answer to this one is e squared. Because remember, if they write in ln, n stands for the natural number. If we were to write this out, log base e of x equals 2, there's the base, there's the exponent, there's what it should equal, so it is e squared. Okay, now this one is a little bit different. 2 to the negative 4 equals 8 to the x. Good there? So this is going to be 2 to the negative 4. We want to write them both as base 2. So this is going to be 2 to the 3x. Is that okay? That work right there? So I can finish this off by saying negative 4 equals 3x. So x has got to be negative 4/3. There's our answer. Okay? So they don't take long, do they? Even if there's a bunch of problems, this is just good, quick practice about the relationship between exponentials and logs. Okay, let's take a look at this one here. Very good. Okay, we could take the ln of both sides, or if you were to just say, well, that's an exponential form and I don't know what the answer is, let's just write it in a logarithmic form. Okay. Now I like Elaine's idea a little bit better. Let's just take the ln of both sides, because if I take the ln of this side and the ln of that side, what do these two functions do to each other? What does ln do to exponential base e? They undo each other. So I get a 5x here. This is ln of 20. Now you do have to get used to this. Okay, and I'm going to tell you this today, and please think about this just a little bit over the weekend. One thing that's a little bit uncomfortable when you start doing lots of problems with logarithms, which is what we're going to be doing over the next couple days, okay, is you look at this and go, that just looks weird. I would feel much more comfortable if that were a number, okay? You need to get used to the fact that you can treat this all together as a single number. Don't throw it into your calculator because it's going to be some big, long, ugly decimal, okay? Just think, if this were 5x equals 22, I'd divide both sides by 5, right? Well, I do the same thing right here. I divide both sides by 5, and I get x equals the ln of 20 over 5. Now, can I cancel the 5 with the 20? I can't. For the same reason, if I had radical 20 over 5, I can't cancel the two of those. Okay, because that's not really a 20, it's a radical 20. This isn't really a 20, it's the ln of 20. It's the exponent that goes on e to make a 20. Okay? So there's your answer right there. That would be an exact form. Did you have a question?
Yeah. Well, are we supposed to find out the round form?
Okay, this is the exact answer. If you threw that into your calculator, go ahead and throw that in for me, would you? Okay. What is it? Okay, that's the answer as a decimal approximation. Generally speaking, and again, this you also have to get used to, we like leaving answers in exact form, okay? So ln of 20 is much better than ln 20 over 5 is much better than 0.5991. Is that what it was? Okay, all right. How can we check to see if this is actually true? If that is the equation? Yep. Yeah, we could take E and do 5 times 0.5991 and see if we end up with a 20. Okay, it would be close, right? We did some decimal rounding there. Okay, pretty darn close. All right, any questions? Okay, I do want to show you one more thing. I want you to take a look at this problem right here. Can anybody think of another way that I could do this, employing the idea that these are inverses? Yeah. Okay, so I'm going to write this as log base 2 of 8 to the x is the same as 2 cubed to the x, so that's going to be 2 to the 3x. Is that all right? Okay, now I've written them so I've got a base for the logarithm that's 2, a base for the exponential that's 2. They're now inverses. Okay, log base 2 is not the inverse of exponential base 8. But if I change the base of the exponential so they match up, this undoes that, and I get 3x equals -4, and there's my answer of -4/3. Very good. Okay? Any questions? Okay. Logarithms are, okay, even though they're the only thing I took my book home for in high school, logarithms are pretty darn cool. Okay? They have a lot of really neat properties, and we're going to learn some more of those properties next week. Okay? All right. Any questions? Okay. Let's see. You've got 20 minutes.